And new topic for today is called databases. And what is a database? Theoretically, if you look on this in very broad view, database is any organized collection of data which is stored and accessed electronically on a computer system. And of course, before computers, databases were also stored on paper and in shelves. And database management system is software that enables users to define, create, maintain these data, control access to them, etc. But if you look on this broad definition, then question arises, why don't we call just file system with files and folders a database, or collection of plain text and rich text documents, or spreadsheets, or any other data you may have, like videos and audios and other collection of data. So these are different kind of databases, but these usually are not called database management systems. These are more general purpose, maybe not so general purpose, for example, if you do your music collection. But when we talk about databases today, mostly we assume that this collection of data is very well structured, and it's predefined. It allows you to do different kind of operations, and so that also these are not some of these different kind of office applications and office documents you may create as your collections of data, because these fit to this more wider definition of what database is, but they do not fit this definition of different kind of database management systems. So important part for these databases, which are actually specialized database management systems, is about files, records, fields and relations between them. So you always start with some kind of structured data, and the structure is predefined in your particular database. So you have different kind of fields like text here, number here, text here. And so these columns here are vertical, are called these fields, and these horizontal items here are records or entries. And if you look on such structured data here with just one sheet or table here, there is no any difference between spreadsheet and between database. But in database, what you can do is that you may have these different kind of structured records. In this case, there is some structure which is called regions, some other structure called sales, and some other structure called salespersons. And then there is some relations between them where these databases are different from just spreadsheets. And you may create some very simple database in spreadsheet, and for you, business could be something about students and courses. And then we can predefine some structure here, ID. And here let's say name. Okay, also ID. And that would be our general purpose spreadsheet used as a database, and here we may assign unique identifiers. And then here we have one problem about relations between structured data. And if I create spreadsheet like this, here I have a problem, because there may be that one student is participating to several courses. And there may be several students participating into the same course. And some score here. And management of such particular table is quite hard and error prone. And we can do it in a such way, but it will not look nice and management will be quite ugly. So what can we do better? We can convert this general purpose spreadsheet system to more like a database with more structured data, and we put these things in different places. For example, here we have spreadsheet called courses. Here we have spreadsheet called students. Then this is not needed. And then we can do it very precisely. And then to say which student is participating in which course, we can create another spreadsheet. That would be somewhere here in the middle. And we have and we just say student number 1 is participating in course number 1 and number 2, and student number 2 is participating in courses number 1 and number 2 as well. So good thing now here is that here we have data with the same data structure, and here we have data with the same data structure, and if we need to refer to them, we just use these identifiers to say how these data structures are related. What is not so good here is that it is still quite error prone, because we may mistype something, and all these relations here are done manually with our organization and understanding of this data. But in real database management systems, when you declare these relations, and the relation here now is following: we relate from this intermediate table how students are participating into courses to identifier with students sheet here, and we have another manually managed relation that with this number here we refer to everything in courses table here. And of course, if we need to add more data, for example, if this is just a final score, then we can add something like student course scores, and here, depending on how we say, and here we say these identifiers, let's say. But if this number n here is undefined and maybe many, then again everything here should be reorganized from columns here to something like this. And we say that first student in first course, and first got this number, then in second time and third time he or she got this number, etc. So anytime we need to make many relations here, we may just introduce one new table here where we do with this duplication in such way that everything what we may describe here as fixed columns or fixed fields here, we may convert it to rows where number of rows is unlimited. And what is important here is that in such spreadsheet or pseudo database where these relations are done manually, what we say as a title here is predetermined with design of our database management system, but number of rows is theoretically limited. In practice, it's approximately 1 million records. Last time I checked for Microsoft Excel and LibreOffice calcs. So then if your structure is the same, you just add more and more records here horizontally in these lines. So your database design may be with fixed number of particular scores here, or with floating numbers here, where you just say which this score is in this particular course and student, and then you may have very many rows here. And everything what I have to do here manually to resolve this particular identifier to particular entry describing either student or course or something else, in general purpose spreadsheet I have to do manually, but in database management systems it has means and tools that if I declare this relation, then just entering this number allows me to get all these related data about this particular item to which I refer to a particular table, which would be sheet in spreadsheet, and to a particular record. And what is important here, do not mix up two different things, design view and data view. An important part about database management system is this discovery that if we have some spreadsheet here, let's call it table as it's called in database management systems, and we enter some kind of data here, and then we determine this structure types of fields, lengths of fields, and meaning of these fields, etc. Here, in this case, in this header, but in real database management systems, that table would look something like this. Let's say type, name, and type 1 may be integer number, name may be ID, length may be 4 bytes, and table may be. And here I'm using different table where I actually describe my design of this student table. And what is very important here is that even though meaning for records and rows here is different, but it is still the table, and so discovery of these database management systems and relational databases is that when you describe design of something, you still may use the same engine, the same database management system, where you use tables to describe tables. And that is very important thing about database management systems. So that here is table representing data, but here is table representing structure of data, but we can still use the same database management engine to deal either with this table, only with this table. Only difference is that particular meaning for what we have here as a column or field and as a row or record into this table is different thing. And so, because meaning is different but management is absolutely the same, we can use tables to describe tables with the same database management system. And that's why these database management systems are so elastic and so customizable, because what they actually allow you to do is to manage tables. But then, depending on what you put into these tables, you may manage completely different data structures and completely different business. And then, depending on some kind of databases, you have other means how you can enter data and recover them back. For example, here looks like some kind of Microsoft Access database with very many subforms to enter some structured data there, and then you can get different kind of output out from there with different kind of reports. And particularly when we talk about different kind of databases, in many cases we refer to these relational database management systems. So that means that they allow you to create many tables into single database, and they allow you to define relations between records and entries in these records in different tables. And these relations, when they are defined, they are managed automatically. And if this is the case, so then these are called relational database management systems. So, and then there are two different kinds of these relational databases. Initially, in older times, there were database management systems which stored these data into files and folders. For example, if that would be Microsoft Access, that would be single file with extension .mdb. Or if it is LibreOffice Base, single file with extension ODB, Open Document Database, ODD. And there are other. So how do they work? One of the things is that these relational databases also allow multiple users to access the same collection of data, the same database, and work parallelly and independently. So you can put this Microsoft Access database or LibreOffice base file somewhere on shared file system in your local area network in your office, and then everybody who has either LibreOffice base or Microsoft Access, they can open this particular file and do manage some data. Then it works in a such way that each of these database management systems run on their own computer, and they read, write and change some data inside this particular file in shared way. In general, it works in such way that if it is put in one single large file, they can read and write only some portions of this large file using index to say I want to read and write from this place to that place. And this approach worked very well 20 years ago, when most of databases were located into offices, so everything here worked in local area network, and each who needed this database accessed this shared files and folders in a shared file system. But it doesn't work very well when you need to use internet, because this exchange of data is very verbose and it is not encrypted. So that means if you try to use such approach in internet, then everybody who is between your database management system and your data can read this data as an open book, of course if they understand this data exchange, how exactly Microsoft works and how exactly LibreOffice works. And because of that, there are other set of relational database management systems where you have so-called database management system or server. And the server in general works in the same way as Microsoft Access works with files and folders. Only difference is that in this case you usually just have a single server. It may have multiple threads or multiple processes working concurrently for performance reasons, but in general it still reads and writes and changes some files and folders into this internal structure of that database. But exchange of data between clients is different. They do not use shared file system, but they use internet connection. So these clients are connected to a database management server using internet protocol. So they can connect to this server from any place where this particular address and port number of server is available. And instead of reading, writing large chunks of blocks of this file here, they use structured query language to ask very concrete and specific subset of data to be returned. And in most of cases, they send either text as a commands in structured query language to the server and get structured data back, or they may also send some binary code there as already interpreted sequence of operations what this server should do. And again, in general, this connection between client and server is not encrypted, so anybody who is between this client and this server can read exchange of data like open book. But because it is network connection, there are different ways and utilities how you can encrypt this data transmission before you actually start talking to this server. And this approach is used for larger systems like different kind of web applications, different kind of management systems. For example, if you use some web application, then there is web server, there is database management server, and there is this relational database behind it. So they use this particular architecture how to make it work. And so here is more details about these relations. If you have some structured data, serial ID, name, login, age, and no idea what is GPA here, but definitely it looks like a floating point number. And you have some other table like course ID, instructor, quarter, and department. Then you can use keys to establish how these relations will work. So key is particular field which will be used as identifier for records in your data structures, and there are two different keys. Primary key is like this field for students, identifier for student, and then there are foreign keys, which are these keys, where you write these keys here, but their source, you refer to them. Their source comes here either from students table or from course table here. So primary key is unique identifier for your records, and foreign key is referrer or relation, how you refer to particular record in some external table in this database. And here is visualization of these relations with primary keys and foreign keys. So here in table student, serial ID is primary key, but here for table enrolled, which in my example here would be analog of students courses table. You say what is course ID here, what is grade here, and what is student ID. So this field here and these records are foreign keys relating to primary keys in this table. And also relational databases work so well because they have very sound and precise mathematical background as basis of them. And basis of these relational databases are relational algebra. So relational algebra is about collections of data and collections of something. And this something may be different kinds like lists, sets, and maps, whatever. But in general that means you have a bunch of something, and this something has internal structure inside it. And then you can do different kind of operations with them. You may select something out, you may project something out, you may create union of them, you may create cross product, differences, sums, and other things. So it is not important for you to know everything here very precisely, but you should know what relational algebra is, and that when you need to learn more details about relational databases, all these practical approaches are based on this very precise mathematical foundation of relational algebra. And so here is again this example I showed you, only names are a little bit different, courses, students, and enrolled instead of courses, students, and names of fields are a little bit different. And if you select something, you pick out some particular records out of your table. And of course, here important part is that this table shows actual data. This is not a table which describes table. For example, here everything is about data. So selection means you pick up only some of these records which satisfies your interest. And so you can select only 2 records here from entire table. And that's if you use these network-oriented databases, then here you may have megabytes of data, but if you select only these 2 records out of it, what you will actually send here through this network is only these 2 records with 3 different fields or 6 data values out of entire table. And when you project something, your interest is in opposite direction, you project or focus your attention only on some particular fields of this table. So again, here you may have hundreds of different fields, but you project out only 2 different fields, name and GPA. And then you may also put together selection and projection with this AND option for this algebra. Then you get only 2 different fields and only 2 different records out of this particular table. And then for these set operations you can add different sets together. You say that union is all these things put together, intersection is only, I don't know. So union is you add one table to another table, either in horizontally or vertically. I think it is vertically. So union without any additional criteria is that you have table A here and table B here. Union is everything from A here plus everything from B here. And of course, if you do not have the same data structures, then it will not be allow you to make this union. But intersection means that you check only overlapping things. For example, you have the same data part here and here, then you have this intersection only where they overlap. It would be something like one table overlaps with another table. So if some of data are overlapping here, here is your intersection. And difference is opposite thing. If you have non-overlapping data here and non-overlapping data here, you have one data set here and another data set here. And of course you may put them everything in rectangular table as well, maybe with some empty spaces here. And so intersection here is that if you have some table S1 and S2, you pick out only these records where data are the same in both different tables. In this case, these are these 3 records. Joins is when you add additional information for these related things, like when you describe students enrolling to the courses, which I called like students courses table, and you just refer to ID, but then you can use these joins to get out of this ID all related data. For example, if here we have this relation from this is for eigen key to this primary key, then we can use joins to get from this primary key all related data in other data fields as well. And now we have this view created out of 2 tables where we do not have any redundancies and duplications, and we see that following students are participating into following courses as one joined or calculated in general table. And how do you do this in relational database management systems? You use so-called query languages to manage them. Why do we have animation here? Strange. And what are query languages? Query languages are pseudo-English text sent to the server, and because it is pseudo-English, it is easier to understand than these relational algebra operands. And there are different kind of dialects for them, but in general they are very similar. Only precise syntax is a little bit different. What exact delimiters you use for values of fields, for names for your tables, etc. But this selection operation, where you pick out only particular fields or columns out of your table, are called selection. No surprise here, because that's how it was called in relational algebra. So you write select keyword, then comma delimited names of your columns, from which table, and then you may add additional criteria where some particular condition here, where values matches particular pattern, where values are bigger or smaller than something, etc. And you may also add what will be order, by which column and by which order, either ascending or descending. And in most trivial case, you just say select everything from table called myTable, and then you will retrieve entire content of this table back, what it has there. Other statement is insert statement. Well, you need to insert new data into your table. So you start with insert into keyword, then you say in which table, and then you may or may not mention in which columns. If you put these values in so-called native order, then you can just say which values should be put there. So first value will be put in first column, second value in second column, etc. But if you want to put only some values in some columns, then you say in which columns, and then you say these values. So if you say like ID and surname here in columns, then you just say ID and surname here as actual values. And here the example is again the most trivial case. You say insert into table values 1 and as a number and AA as a string. So this value will put in first column and this value will be put into second column. And update statement allows you to change existing data. You start with update, you say in which table, and you say set, and here set is not like a set in this algebra, but it's like put. I don't know why they decided to say set, not put, but in general it is because set is collection with unique elements inside it. So set actually here means put, and you say in which column which value, which are comma delimited, so pair of column name value comma column name value comma column name value. And you almost always need to add where condition, because if you will not say where condition, it will update all records in this table. Typical example is you need to change some value of some column in one particular record. you say like update my table, set my column field to AA, and you say where ID is 1, where typically this ID is primary key, where you say that only this record should be updated. And delete statement allows you to delete some data. You start with delete from name of the table and you add where condition. If you will not add where condition, then everything will be deleted from this table. And because of that, typically if you need to delete just one particular record, you say delete from name of the table, where ID is particular number here. In this case again, ID is usually this primary key, which is used as primary unique identifier for your records in your table. And then in relational databases, you may do these queries covering multiple tables, and that's where these relational databases are very strong and good, because when you do this data deduplication here, you almost always want to get some duplicated data back as a general report about your situation here, because looking on these lists of identifiers here is not fun at all. And so then you can select from several tables, and where conditions are very important here, because if you select something from two tables, let's say table 1 and table 2, and everything from T1 and T2, what we'll get here is what they call as a Cartesian multiplication. So your result will be first record from first table and all records from second table. This here, C and D. And then second record from this table and all records from other table. And sometimes you need this, but in most cases you just want to join them properly, and therefore you add something like where ID of table 1 is ID of table 2. And then you get properly joined tables together here, like you use like a glue here to connect this record from this table to that record to that table. So that is usual what you need to say. If you select across several tables, you need to say how exactly record in one table should be related to record to another table. Otherwise you get a full combination of all possible relations between record in one table and record in another table. So then SQL allows you to do different kind of built-in functions, like getting minimum, maximum and average from all these fields, all these records in field. You can count records, you can check for unique set of these records. For example, if you steal some duplicated data there, if you use distinct, then you get only unique records out of this table. You can order, you can group these records in different ways. And then you need to be careful when you start using SQL in different kind of applications, because SQL Server and SQL as a query language is very powerful. It allows to do anything with server. We will not cover in this course about SQL statements how you can create tables and how you can delete them and reorganize entire database, but it is possible. And because of that, this SQL or relational database engine may do more than you intended to do. And one of security problems you may have with your particular application is that if you pass all data entered by user without any sanity check to the server, everybody who knows something about SQL may try to check your server to robustness. For example, here, to check that some user may log into system, you use select statement. You just say select every field from table users, where name is, and here you put particular value of username field in login form, and here you put value for password field here, and everything here is joined as a string, which is then executed as a procedure. And if user is proper user, he or she just may enter actual username here and actual password here, and everything will work. But if this user tests your system for robustness, he or she may try to finish this statement here, and then instead of normal username, try to enter completely different SQL statements there. So, because everything will be executed without additional checks there, some of usernames will be something like finishing delimiter for this field, then select from passwords, or finish everything with semicolon for this finished statement, and then say drop database. And what you need to know about drop database is that with this command you can delete entire database, which is current database. So, and because of that, what is very important here is that when such a kind of applications are created, you do not allow to interpret everything as a SQL statement. So in different programming languages there are different means, but the general idea is here that you do use so-called prepared statements, where you write your statement here for full interpretation as a commands inside your source code. And then when this improper values are entered here, these are not interpreted anymore. They are passed to server as is without any interpretation. So, and if somebody tries to say that username is apostrophe space or space apostrophe 1 apostrophe equals apostrophe 1, so this will not be interpreted, and password will not be interpreted, so server will just check, is there such strangely named user with such a strange password, and that's it. And then you also can use different kind of use of all these joins and selects and selections and operations. These are different kind of use. So use are virtual tables when you can create a calculated table as usually different joined tables from these actual tables, mostly for different kind of review and reporting purposes, to put redundancy back into your data when you need to put everything together. And then important part is about indexing, which is mostly because of speed and overhead for data management. For example, if I need to select some unorganized data here is my table, here is, let's say, identifier and some name, and it is not an organized, this identifier is not ordered, but maybe it's 3, 4, 5, 100, 7, blah blah blah. And if I need to select, for example, where ID is 7, problem here is that if these data are not organized, then I need to go, in worst case scenario, through all the table to find where this identifier is 7. So on average, this means I will need to go till to the half of my table to find this particular record, and it may take quite a lot of time. But if these identifiers are organized in ascending order, then I may use different kind of optimizations, and easiest optimization is divide by 2, jump and divide by 2. So we have here millions of data. First we look what is ID is somewhere in the middle of the table, and then depending on how close we are to our needed value, we jump by 2 either forward and backward, and in this case maybe forward. And then again we look around, jump with approximately half amount of data forward, backward, and so we jump several times till we reach this record. And how can we reach and jump in the middle? Because for structured table, important part is that you always know what is length of your data. So if it's integer, it's probably 4 bytes. If it's string, it's, let's say, 45 characters, etc. And if your entire database is 100 megabytes, you know how much space each of these records takes, and you can do this so-called indexed search. And if here number of steps we need is approximately 1/2 of n in this unorganized way, here with this jump number of step is logarithm of n, and by base 2 if we divide it by 2. And so this means in one case speed versus amount of data, so steps and data, increases linearly, but in second case it increases logarithmically, so it is much faster for large amounts of data. But you may say, okay, linear approach is not so bad, but every time you need to join 2 different tables, and you use it quite frequently in any non-trivial database. If here amount of step is n, and if here amount of step is, okay, n divided by 2. I think I wrote it incorrectly, divided by 2, and this is, let's say, m divided by 2, then average amount of steps to join some data in these 2 is n divided by 2 times m divided by 2, and it is actually, if we divide by 2, ignore, for large amounts of data, divided by 2 or multiplied by 2 is not important. It is approximately n times m. Or if n and m is approximately equal, it is n squared. And this is not good, because then if here is amount of data increasing and here are amount of steps, it goes in a such way, and if we need side table joined together here, then we have n cubed, etc. And then that is very bad. But if you use this indexed data and you can jump here and you use logarithm amount of data, then you have logarithm of n plus times logarithm of m, which is approximately logarithm of n with some multiplier here. So, and then of course it is very different if your time or number of steps increases in such way very dramatically or increases much less dramatically here. And that's why indexes are used. So these are very good for different kind of searches and operations. And the only problem is that if you need to sort your data in indexed way by many fields like ID, name, surname, score, or whatever, then you need to add index for each of these fields. So you actually have your actual data where ID is used as a primary key. So you will have ID1, Janis, blah blah blah, ID2, blah blah blah. And then you will have, if you need to search by name and surname, you will have another index with, let's say, name starting with A, like, I do not know, Adams, which is ID 33, then Betty with identifier 165. So you will have another index or another index entry which is now organized by name, and then it has these relations or references to actual table where these records are by their primary key. And if I need for surname, again I will have indexed table here starting with A, blah blah blah, references to B. So this adds extra data, but these extra data are not so good, but usually with all these fields your table becomes approximately 2 times larger than initially, but amount of operations how you can need to do them is still very good. But of course, because of these added indexes, then all these modification operations becomes slower, because you add or modify not only original data here, but you also need to manage and deal with indexes here as well. But in most of cases, in large sets of data, indexing is always good. And as a rule of thumb is following: if your amount of data is not larger than hundreds of kilobytes, or number of records is not larger than few hundreds of kilo records, then you may not need to use indexes, it will still be pretty fast. But if you start dealing with mega bytes of data or mega numbers of records, then of course dealing with indexes is very important. And so there are different kind of indexes. I described you what primary index is and what secondary index is, and then there are different kind of organizations of these indexes, because very stupid thing to organize index is following: that if I need to add something, some record between Adams and Betty here, and I do not have place, of course, either for primary data or index here, so I need to shift all these data, maybe megabytes, after this record just by few bytes, only to insert something new here. So it's not organized in such way. Usually they use different kind of links to links, etc. So if you need to actually add something, there are neither data changed after this record nor after these indexes. But what you do, you jump in some empty place, then you add blah 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 here as a data, and then jump back here to this record as well, and then again you jump out, add, and jump in. So everything mostly is organized as links between these records. So and similarly, if you need to delete something, you delete it, and then you reorganize links in such way that if you need, you still may reuse this data for later modifications. And so where different kind of relational database management systems are used, they are used in almost any large non-trivial application if you are connecting to some web application or other system which is not something very small running on your local computer, then probability is very high that relational database is used behind it to organize these structured data and their relations. And they allow you to use the same principles to organize different kind of data. You just need to say what exact data structures you will have, how these data structures will be related each to other. So you can use the same database management engine with different data in absolutely the same way, only actual structures of data will be different. So it's very efficient in terms of provided functionality. And so also all these databases have built-in administration for access control, what you can modify, what you can see, etc. They automatically provide integrity and security. Also they deal with concurrency control. For example, if there are several users working concurrently on the same database and both want to modify the same section of data, then automatically this database management system disables access to the second person to this data. Then when first person is finished modifying this data, only then second person may access this data and modify again, and all different other things. And then some of you who is interested about technologies, you may have heard something about so-called NoSQL databases. And if you try to resolve this naming here, then this NoSQL means something like no structured query language databases, where structured query language is that you may write these select statements and insert and delete, blah blah blah. But as it usually happens, these buzzwords are not assigned correctly. And similarly, as black holes are not black and dark matter is not dark, NoSQL databases are not NoSQL databases. What they really are non-relational databases. So relational and structured query language are related terms, but of course it's not the same. SQL is structured query language, how you manage these, and many of non-relational databases actually support SQL as a management language to do them, but what they do not support this automatical navigation from foreign key to primary key. For example, basic for relational database management system is if you saw primary key here and foreign key here, then when you join everything, you just say what kind of conditions you will have for join and everything will work automatically. But for these non-relational databases, they are organized differently. In most of cases, they are like tree structure, not table structure. You start with some root element and then you go into more and more details about elements. And if you don't need these relations and join tables together, it works pretty well. But good thing about tree-like structure is that you can store or hold these tree-like structures in distributed environment. So, and for very large systems, then may be that some part is on server 1, some part is on server 2, and everything works pretty nicely, so you can load balance between these servers, etc. Typical non-relational databases are like MongoDB, Redis. What else? For Google there is Firebase. That is quite frequently used as a cloud service for Android developers. So these are non-relational databases, and their structure is like you say what is your root element, like my root element will be my application, then inside my application I will have students and courses, and then inside student I will have identifier, name, surname, etc. But these relations, for example, between some part where you have students and some part where you have courses, will be much harder to manage because they will not provide built-in support for resolving these relations automatically. So why are used such kind of database? Because they work very well for very large data. And like all these large web applications, like social networks, Twitter, Facebook, and Slack, and WhatsApp, or whatever, as far as I know, all of them use non-relational databases because they are much easier to scale up for very large systems. And if you use some social network system and it can calculate with precision ±1. For example, from all the social networks I'm using Twitter, and I know definitely that Twitter can't count precisely how many unread notifications I have. Why? Because of this distributed database, it can't be absolutely sure how many of some of these entries are not processed in some part of this distributed system and some part of that system. And they have so-called eventual consistency. So eventually Twitter may count how many unread notifications I have. But it's only eventually, which means in infinite time. But if I will do check precisely, and similarly for YouTube, you may see that it shows that there are 2 comments somewhere here, but neither comment is actually shown up to you. So this means number 2 has come to you for reading, but actual comments are somewhere else into this non-relational database. So on these non-relational databases are very popular when you need to handle very large amount of data, which you probably need to distribute over several concurrent parallel databases, and where your calculations is okay that you may count with precision ±1, ±2, something like this. So if you need to count money, you still always use relational databases, because for a relational database you may ensure all the time that your money will be always counted very precisely. If your speed and performance is more important than very precise data, then you may use these different kind of non-relational databases, which you still may manage using structured query language, even though these are not relational databases. And that probably is it about theory about databases. Do you have some questions or comments? So now about your practical exercise or homework for this activity about databases. You open this homework page, go to the databases and show here, and what is required. You are required to connect to this network-oriented database called MySQL. That means this is this kind of database which allows you to transmit data through the network, so you don't need to get direct access to files and folders of this database, like for Microsoft Access or LibreOffice Base, but you need to connect to this server. And the easiest way how to manage MySQL server is to use specific application called MySQL Workbench, and it is partially open source system, but if you do not want to compile it from source code, then you may get already compiled closed source binary version for it in this dev.mysql.com website, and you choose a particular operating system. Unfortunately, they do not, they have all these mostly widely used: Microsoft Windows, Ubuntu Linux, and 3 different kind of Linux, and also source code as well. So you choose which one you need. For example, if I use Ubuntu, here it has 2 different sets, larger and smaller. And the difference here is that this larger one has some additional debugging tools put into it. If you need to save disk space, this smaller version is okay, and we may check how it looks for different operating systems. For Microsoft Windows only one particular option, and for MacOS also only one. So only for Linux users there is more choices to have. So you download it and install it. I hope that this will not be very hard for you. And when you have installed it, then you can open it. Let's close these which are not used. On home page should look empty here. So here are I have predefined set of different kind of connections, but you need to create a new connection. And we need to discuss a little bit about these connections. I hope you understand something about networking theory and practice some time ago. So this large box is computer, and this small box is network card. And inside this computer, some operating system is running. And of course it has device drivers to manage this actual hardware. But then, if Internet Protocol is supported by this system, there is virtual network card called localhost. And its address is 127 blah 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 or 00001 blah 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 for Internet Protocol version 4 and Internet Protocol version 6. But in general it is implemented programmatically as a shared memory between other processes running concurrently or pseudo-concurrently inside this operating system. And one of these processes is MySQL server. And what is important is that for security purposes, by default, such systems which are usually used as a backend for something else, like There may be Apache web server, which is actually listening on this physical network card, but MySQL server is listening only on this localhost interface, and that is problem for inexperienced beginners, because if you have your computer here, and of course you have operating system running on it, and you have different apps running on it, and you also have localhost interface here implemented programmatically. If you have this MySQL workbench running as one of process on your system, you cannot connect to this localhost interface running on remote server, because localhost interface can be reachable only from other processes running inside this operating system in this machine. And one of the wrong ways how you do this, if you want to manage this MySQL server, you reconfigure it that it also will listen and will accept incoming connections to this physical network interface. Something like this. For example, here, currently, this is my own computer, not remote server. You see that it is listening on address 127.0.0.1, but because of how localhost interface works, any other number here will still point to the same virtual network card. So you can reconfigure that this server is listening on all possible interfaces, and then this means in all these links which are configured to my computer, it will accept incoming connections. But this is wrong way to do, because it exposes additional application to the internet with all these things where you risk with different kind of security vulnerabilities. Proper way to make this connection is following: that you have another application like SSH client and SSH server running in both ends of these computers, and SSH server, similarly to Apache server for web server in general, is listening to physical interfaces as well. So you can create connection from your physical card to physical card of your computer to create SSH connection. And that was one of your exercise to your networking exercise. For example, you can create SSH connection either using SSH client in Unix-like systems, what was password there? That's do. And now I'm created a remote connection to this remote server, because now I'm in server called tools with username ARTS. And if I check who is there, so I can check. So now I have created remote connection to the remote server using just text interface. But SSH also may be used as a transport protocol to transmit some other data. And if you configure your SSH client in this tunneling way, what you can do is you add listening port or service on this end and listening port or service on that end. So you create something like virtual pipe here for data transmission. And then you can send some data through them, like you connect to MySQL workbench to this end of this pipe, some listening process on your local computer, and then this other process, listening process on remote computer, will spit out this data to localhost interface to MySQL server and back. So that is this SSH tunneling. Actually here it also goes through the localhost interface. And for example, I will go into details later, but I can create tunnel. So I don't know which one, but some of these processes here creates another process on other end of this server, which creates this listener on that end. And here I know which is this number of port here. I have created process which is provided by this SSH application that on my own computer and localhost interface there is listening process responding to port number 3307. And if I do something like MySQL as a client interface, I don't remember what is. So I could connect if I would do it properly, I think. Should be correct. What was password? Maybe I need to check password again. Okay, maybe I did it in opposite end. So I can create such tunnel. That's what I wanted to say to you. But particularly for MySQL Workbench, because this is very typical scenario, how do you do these things? Everything here is already built-in feature, so you don't need to make all these connections with separate general purpose tools like SSH client and MySQL client, whatever. You may just create everything in one shop in one way. So therefore, when you create this connection, and I will call it this is username RSS, and instead of standard TCP IP, and so this you would use if you use MySQL server and MySQL Workbench in the same local computer. So you can connect very quickly through this localhost interface. This would be if that would be local area network, and it would be possible to connect to it using this IP address. But in this case, because this SQL server is remote, we use standard TCP IP over SSH. And so the settings here are settings to establish SSH connection first, which also encrypts data between your computer and other computer. And then inside this SSH connection, you transmit all this data for MySQL Workbench and MySQL Server without additional encryption, because that connection is already encrypted, as usual. And only thing here is that you need to know how to write here. So when you create SSH connection, you need to create it to this remote server, which in your practical exercise is tools.lv, and you can add port number 22 here, but because it is default port number, you may skip it. Your username given is ARTSS. You may use different kind of authentications like exchange with public-private key, so then you will not need to write your password all the time, but of course you can save your password here in MySQL Workbench as well. And here you don't change anything, because this IP address is IP address when you already have established this SSH connection. So you have created this tunneling, and then you say to which interface you want to connect. And of course you want to connect to localhost interface where this MySQL server is listening on this remote server. So you don't change anything here. Default port number for MySQL server, localhost IP address, but username here is ARTSS as well. You may test connection. And if you are optimist, you can save your password in keychain as well. And see here, I passed authentication successfully, because this other prompt for password is to connect to MySQL server. So first I created this tunneling session using SSH protocol as a transport, and now I need to authenticate to the MySQL server. And if I type it correctly, I can save it and hopefully it will work. And everything looks successful here. And to make your life easier here, you use the same username, the same password, even though these are two completely different users. One is user to create a remote connection to remote server using SSH protocol, and another is username and password to connect to the MySQL server. And then you save it, and then you double click, and if you save with passwords, it should be opened. And what do you see here? First, you may see, because MySQL Workbench is administration application for SSH MySQL server, here you can check different things about service status, how it's working, what are created client connections here. Here you don't see anything because you do not have permissions for that, but you can see, for example, at least server status here. So that's one tab. Another tab is schemas, or these databases created on this remote server, and you may see here only one database called ARTSS, and it doesn't have any views, doesn't have any stored procedures or functions, but it has two different tables. And what is also a very good thing about MySQL Workbench is that most of your management operations you can do just by right click and entering data, so you don't need to know SQL as a language directly, because you can generate these statements using this graphical interface. For example, if you want to select all the entries from the table called entries, you right click, say select rows. If there will be millions of records, only first 1000 will be shown. And you choose it and you see that it generated following SQL query. And here is virtual table created for you as a spreadsheet where you see actual records. And if you just type something here and say apply, it generates this SQL statement for you automatically. So if you want to see it in full view. So what I did here, I just typed my entries into this virtual table, but what I will actually send, I will send this query to the server, insert into, name of the database, name of the table, name of the list of names of the fields, and values here. And if I will say try to apply here, it has some built-in support that you can't do absolutely stupid mistakes. So operation failed because here, for example, for column ID, you can enter only number, and here only number, but these are texts. These are not just numbers. So you should be careful that when you finish it, that you don't see error messages here. And if you did something wrong, you can say revert here, so that stupid change didn't work. Remember that this is virtual table created on your MySQL workbench, and if you do something like this, it is only temporary data inside your MySQL workbench before you will press apply here and send these instructions to the server. And if these instructions will not be executed successfully, all this is just your scratchpad, so these are not real data on the server. And then you can also select something from other table here, and here we see much more different records created. And what is your actual homework? Your actual homework is to prove that you can somehow manage to do 4 basic operations on the databases. What are these 4 basic operations? When you talk about databases and persistent data in general, you may see abbreviation called CRUD, which is abbreviation from create, and these are 4 basic operations you may do with persistent data. You can create new entry, you can search for them. So in SQL, that would be insert into. For reads, that would be select. For update, that would be update. And for delete, it would be. So this abbreviation is not exactly the same as you have your SQL keywords for these statements, maybe because CRUD just sounds much better than ISUD or ISUD or whatever. So you need to prove that you can read some existing data in table, you need to prove that you can create new record in the table, update existing table, and delete something from some table. So you will not need to prove any skills about relations and all indexing, all this advanced stuff you will learn by yourself if you will need such need. So what you need to do here, I showed you how you can select everything, but you may minimize amount of retrieved data. For example, say that limit number of returned records only to 1. And if you execute following statement, you will see only one record returned, which is first record, because this is primary key, and primary key by default is ordered in ascending order. And from this table, you need to use one of first free record from this table to do it as an input for other table. And my recommendation here is following, that you copy it, copy row, and you store it in some simple plain text editor. And so this is table where you need to prove your skills about searching and about deletion of the data. So if you say, so this record is taken by me, you just delete it. So, and by the way, these hashes, they have some secret here. That identifier here is actually related with this hash, so it is not random number, but it is specific key here hashed to check that you actually used this record as an input for this other table. And what you do here, you say delete this record, and in my case I will want to delete a record with identifier number 1. So that, and remember, I can delete it because I have stored my local copy here. You may do it in different way, but if it will happen that there are several students working concurrently, if you will not first delete your taken record and use it for other parts of this activity, of course there may be some inconsistencies who use which record, and therefore it's proper is that if you decide that you take it as input for your other table, then you delete it. Double check here that you are deleting identifier number 1 and execute it. And where is my output? And here I see that this was executed successfully, one row is affected, and if I will, for example, double check, I will see that there is no such record anymore. If I will try to recreate this record, it's not required, but if you just want to check system for robustness, again here are built-in security features. It will say following: insert is not allowed in this table. So in this table you are allowed only to delete existing records which are taken by you. So that's first part of this CRUD part. I proved that I can delete something using MySQL Workbench. Second part is that I need to prove that I can search something and insert and modify in second table. Before that, I need to execute, okay, let's execute it in new query. So here again, I didn't select everything, but I selected out only last record from this table. how do I know that it's last record? Because I still limit number of records to 1, but I order it in descending limit. So this is not first one record, but last one record. And here I will need to check what is identifier used as the next here to insert something in my table. And this identifier is here provided to you by this hashes table. So what I need to do, I need to say, we do create something like simplified blockchain without actually calculating hashes. I need to say that in this chain of events, my next identifier for inserted record will be 1. Then identifier will be 1, where it comes from this identifier, which is first unused identifier. And then here I need to put this secret hash here and this one, but I need only first 4 letters for it and something like this. So here in this virtual table I actually have done 2 things at once. I modified one of existing records and I created one new record. And if I say apply here, it doesn't fit. Where is my apply button? You'll see here that because of these 2 different operations, 2 different statements are actually generated. One is update existing record, set next ID is 1, where ID is 0, and insert into new entries with following values. You can double check that everything looks correctly here. It looks good to me. And no errors here. And then I have done. And if I refresh and look for last record here, I think I probably pressed this button, which is execute only statement under cursor, not this button here. And now last record in this entries table is this one. And as usual, your proof of work actually should be submitted in file which is uploaded as usual. So here, this is just your sandbox. What will be actually checked is, as usual, particular file submitted here in my web server. And this proof is this actual data what you have inserted into entries table. And you need to show what was previous entry before you entered your new one and what is your created, let's say, previous updated entry and newly created entry. And here again you can use just selection criteria to show both of these fields, where ID is either 1 or next ID is 1. So ID is 1 will be for your newly created record, and next ID 1 is for last previous record which you modified. And if you execute it, you see these two records. One is modified by me and another is created by me, and then some other student will modify this field here and will create another record after that. And here you can do it in different ways. You can right click here and say copy raw, open some text editor, or if there would be many data, you can export everything here with this identifier. Let's say where it was. And work is number 8. But because of these different approaches and different tools, actual result may be a little bit different. You need to check that this file doesn't have delimiters and doesn't have around values of these fields and doesn't have this. So if I right click in MySQL Workbench, it wraps everything into single quotes. So that's not needed. Let's replace. I call this single quotes need to be replaced. All in this case, this first row needs to be deleted, only these data are needed. And then you upload this file. I think I saved it on this one, I think. So I think that this particular approach is the most appropriate most appropriate approach how to do this, because this is the most user-friendly. But if you know something about basic principles, you can also do as a workaround solution with different tools. For example, if you know other tool, for example, for PG admin, I think does it works well with so this tool may be good as well. Other approach may be rudimentary approach using just text oriented tools. So you can do something like this. First you create SSH connection to remote server, either with PuTTY or with built-in SSH client. And then you use MySQL client, which is text-oriented client on the server already. So please pay attention here. Even though I have my terminal here on my computer, all activities what I will enter with keyboard and what I will see actually will come from this remote server. So I can write MySQL user artss and also use password as well. -u -p. enter password, and then all these things what were described here, you can just copy paste from here and update where it's needed to see in this table here. So that is other option as well. So doesn't look so nice, and you need to know what you need to write here, because there is no any possibility to generate these statements. You need to know what to write, but if there are some examples, you can do it in following way as well. And then you can use any other tool. For example, if you are familiar with Microsoft Access or LibreOffice Base, they also have built-in features to connect to remote databases. Only problem is that they do not have built-in feature, at least last time I checked, to do encryption, because this remote MySQL server is not listening to the public address of this remote server, which you can see like it is not listening on this public address, it is only listening on localhost interface of that remote server. So what can you do? First, let's double check that I created properly this remote connection. So we need to create SSH tunnel first. And then this is forward tunnel. So here, if you are using PuTTY, it also shows how to do it in PuTTY, for example, for Microsoft Windows. But to show how can you connect it with general purpose, so which address was AAA? This is local and that is remote. I think I did it correctly. Yeah, and I have created SSH process which listens, and why I use X3307, because on 3306 my local MySQL server is listening on my physical computer. And then I have created this SSH tunnel either with PuTTY or with SSH client. I can just create LibreOffice database, because I do not have Microsoft Office. And then I need to connect to the network database, and you see here, for example, Firebird is not relational database. This is object-oriented tree-like database, but it still understands SQL. And therefore, when you say this is no SQL database, you are saying it wrong, because it is not a relational database, but it still understands SQL as a management language. But I need to connect to MySQL server. And here, I think this one, I don't know. We'll see. Let's say TSS is localhost. Remember, I'm writing localhost here because I have created this listening process on my computer through this SSH tunnel, because you cannot just write this public address of this remote server here and this port. because MySQL server is not listening on public address, it is listening only on this localhost interface. And so port number here is this one, otherwise I would connect to my local MySQL server. And I think that's it. PSS, need password. What was password there? That's and here, instead of MySQL Workbench or pgadmin, I'm using LibreOffice Base or Microsoft Access as my management system. So I can open this table. I can see data here. Again, probably if I will write something incorrect, it will not work. I do not know how to say apply. When insert new record, next ID field should be empty. Now I have duplicate entries, so you can't describe any garbage here. I don't know how to undo this. I can just close this and open again. And similarly for this table as well. So you have different kind of options how to do these things. Your only limit is that you cannot connect to this remote MySQL server directly using public IP address of the server, because it is listening only on localhost interface. So first you need to create SSH connection, and after that you can create this connection through this SSH tunnel. So it became very slow to me, it is not responding here. So definitely Microsoft Access or LibreOffice Base is not the most useful client to connect to this remote server, but I just used this approach to show that SQL is well-defined and organized protocol, and if your client uses this protocol properly, you can, and your server uses this protocol properly, you can mix and match different clients and different servers, and if they still will use the proper dialect of SQL language, then it will work. So if you use not bash, but if you use remote connection using text interface, then only thing you need to do is you need to update these commands still, because here everything about particular identifiers is placeholders. You need to update these placeholders to proper values, but otherwise all needed minimum amount of needed operations is given here. So if you do copy and paste and update into this pasted code properly, then of course one of easiest way is just to use text interface, create SSH connection first, run MySQL inside it, and by the way, I think this is in Latvian, but if you are not familiar with MySQL client here, I can add a reference here. This may also be useful. I probably will update this task with additional information. And also one important thing is, because this is more specific, this task is more specific task as for networking, the same rules are applied for your unsuccessful experiments. If you will get too many authentication errors to this server, your public IP address will be added into banned list, and then this server will not respond to you in any way, including ping. If you don't get any response, then again you need to check what is your public IP address, and you need to email this to me to say what particular IP address should be removed from this banned list. And I think that's it about practical exercise. Do you have any questions or comments?